Hello and welcome to Pharmacy 101. I'm your host here, Julian. And in today's video, I would like to talk about antiherpes drugs from a chemical standpoint. So in general, antiherpes drugs can be classified into two categories. The first one being nucleoside analogues, which of course includes purine analogues and pyrimidine analogues. Then the second category is the phosphorus derivatives, which includes phosphorinate. So in this video, we will not talk about phosphorinate and only these two categories, subcategories, purines analogues and pyrimidine analogues. So in order to remember these drugs more efficiently, a knowledge about the structures of these nucleosides such as adenine, guanine, thymine, uracil is pretty much needed. So I already make a video about ways that we can use to remember them more efficiently. It will be linked in the description below. Right, so without further ado, let's look into the drugs. So here I have drawn four structures of guanine, right? And how do we know it's guanine? It's simple. In comparison to adenine, because guanine will have a guanyl multi here, guanyl group or guanidine, right? So now let's take some steps to modify these structures, shall we? Right, so the first structure, we will actually make half of a pentose sugar, because it's very important to note that in order for this nucleoside derivatives to work as a antiherpes drugs, it has to have a sugar moiety here, or half of one, I would say, right? So actually, if you look at here, this is actually half a pentose sugar, okay? And this drug, we call it Aciclovir, right? Aciclovir. Okay, so now let's take one more step here, right? Okay, we have we have basically Aciclovir. Now we add another quarter of the remaining pentose sugar, which, of course these dotted lines aren't there. I'm just drawing for illustration purpose, so that you can see it is actually more of a pentose sugar than Aciclovir is, right? So if you make it like this, there's two hydroxy groups here. We call it Genciclovir. Genciclovir. The I and Y is interchangeable actually. You can also write Aciclovir as ACIClovir. Alright? You can write it as C or Y depending on your origin. Right? So okay, so at this point let me just redraw this structure, okay? So let's draw a purine which includes a diazo ring, right? Then fused to a imidazole or pyrimidine. Okay. Now, if you look at here, can I draw it like this? It's practically the same, just that I instead of placing it down here, I pull it up. So this is just for illustration purpose when we compare it with the next two drugs, so that you can easily identify the differences. Alright, so now let's look at the third drug here. So in this drug, we essentially took this ether group and changed it to the carbon, right? That's all, from here to here. We change this oxygen, which is an ether group, into a carbon, and we make it as Penciclovir. Okay, this is Genciclovir, this is Penciclovir. So while studying purine analogues, it is easier for us to follow a pattern, we slowly add more stuff to the compound, right? or change it a little. For example, we change this ether group into a carbon atom, right? Okay, now let's look at our fourth example for today for purine analogues, right? So for this structure, it's a bit complicated now, right? So now we take these hydrogens and acylate it. We add an acyl group, so O, C, O, C, H3, O, C, O, C, H3. If you draw it out, let me just redraw this. Alright, let's draw our guanine. Okay, okay, now so this would look something like this. Okay, CO CH3, CO CH3, right? And we call it Famciclovir. Famciclovir. So these are 4 drugs here for purine analogues, for guanine analogues. Alright, Aciclovir, Genciclovir, Penciclovir, and Famciclovir. Again, pan-fam. Maybe you can remember these mnemonics, but not really mnemonics. Again, pan-fam. Alright, so that's 4 of the structures here. Now, if you look closely enough, here we have another structure which is slightly different. So all 4 are guanine analogues. Both of them are purine analogues here, but these 4 are based on guanine. Okay, and then these 2, actually just one vidarabine here. I'm just drawing an adenosine for you to compare the structures later on. So vidarabine is a adenosine derivative. Now let me just draw it, and you can compare the difference of it between with the adenosine. Okay, pretty much similar, right? Except the fact that the OH here is actually upwards. Okay, note the 2 difference here. So this is vidarabine, a purine analog, which is an adenosine analog, right? So moving on to the last portion of the video today, pyrimidine analogues, specifically uracil analogues. Okay, uracil analogues. So this this one is an adenosine analog, and these 4 are guanine analogues. So this one, so this is the uracil, right? Let's draw a uracil nucleus again. This is uracil because this is a urea moiety. Okay, now what's the difference of this group and this whole compound? Do you see the iodine here? So, and of course, as I mentioned just now, in order for purine and pyrimidine analogues to become an effective antiherpes drug, it has to have a sugar or somewhat a portion of a sugar here. Okay, now so here it's an iodine. There's an extra iodine here substituted, so we call it iodox uridine. Because this is basically uracil plus a sugar, we call it as uridine, right? So this is uridine, this is iodox uridine. Just one more iodine. Okay, now to the next structure. Of course, you can realize this whole group is an addition. Okay, or since thymine is basically is basically methyl uracil. This is thymine structure. We can call this as a thymine derivatives as well. However, the name of it is trifluridine. Trifluorine, right? So I guess that would conclude today's video. I hope you guys can benefit quite a bit from this short video, and I'll see you next video. Right, thank you for watching.